Oh, we're live. Hello and welcome everybody. Thank you very much for coming along to another Clojure study group. This week we are going to go back to the building of an API that we started a few weeks ago. So in episode 16 and 17, we started looking at building websites and then consuming an API. So we're going to continue looking at that. And we're going to be using Leiningen, the build tool, with a particular template called compojure-api. And so today I'm going to attempt to walk through building an API for interacting with game Scoreboard. So we've got a game, you play games, everybody plays games, and the scores, and we can have an API that will allow somebody to save their scores, to go and look at the scoreboard and see who they are, like the top players are or the top scores are on the board, and then also be able to register a player account as well and see all the players who've got an account as well. So that's what we're going to try and do today. The Clojure API, the Compojure API template gives us, also includes something called schemas, which allows us to shape and define what the shape of our data should look like. So if we get data that's incorrect, then we kind of get error messages around that, so we can fix it. So it adds a bit of protection to our system. Whenever you're building something that's talking to something else, it's always good to have a very clear and testable contract between your system and theirs. And so if they're sending data, then you need to define with some kind of schema what that data should look like. If you're sending data to them, you should also do the same as well. It just is good practice. It's kind of good defensive programming to be able to kind of define what the shape of things coming in and out and going out of your system should be. Okay, let's screen share my entire screen, and let's share that. Trippy. There we go. I will look at. I'm looking at Open Broadcast software, which makes it a lot nicer to actually do these broadcasts, but I haven't quite got everything mastered yet, but I will do. Oh, hello, Pussycat. We're going to cat to join us today. There we go. So in the chat, I put a link to this Serverside APIs, and so we covered this a little bit in detail, but it kind of gives a bit of visualization in what we're trying to do today. So we're building a server-side application. So it's going to run on some server somewhere. We can put it in the cloud. At the moment, we're just running it on our own machines, so it's pretty straightforward. But it's quite easy to deploy this to Amazon or Heroku or OpenShift or any other cloud provider as well, and that'll give you some scalability. So if you've got hundreds, thousands, millions of users, then obviously running it on your laptop is not going to be quite enough, even if you've got a very fancy laptop. Yeah, typically if we need to do some processing as well, then we can also use the capacity of the servers that we're running on to do calculations that support our APIs. We probably don't need that for a game scoreboard, but for other kind of systems, we might need to also do some calculations, some transformations of the data before we give the response to our request. So if we look at this diagram, it's on the screen. So this is just a visual representation I've come up with how Compojure and Compojure API works. There we go. So we've got an adapter. This is our Jetty process. So Jetty is a Java application server that we're running. We can use some middleware. So by default, I think we're using wrap reload, which means that when we run our application and we make changes, it's always going to reload those changes into the running application, so we don't have to start and stop things all the time, which would slow us down. And we're going to define a bunch of APIs. So basically, if you go to a particular web page, website, web address, then we will define routes about what to do if we get a request for a particular web page address. So like this website is practicalli.github.io. Then it's got ClojureScript web apps, which is the application, and then Serverside API, which is the specific page to go. So that renders a specific page. So there's a particular route that gets us there. And that's what we'll be defining with the APIs. And we might define some functions that are handlers that we will use to do some calculations or update data and so on. So we're not really going to use a database this time around. I didn't really want to get into setting up a database and database connection, although we will do that at some point. Ideally, if you've got like hundreds of thousands of scores and you want to keep them, you do need to persist them somewhere. So you probably will have a database or some kind of log that you write to. For now, we're just going to we'll probably just use an atom so we can kind of store and update things and return updates. Ooh, hailstones out there. What is happening with the weather in London? I don't know. But essentially, all these things are functions, and it kind of keeps it very, very simple in what we're trying to do. And then we've also got Swagger, which will give us documentation without having to write our documentation. I will be updating all this code and documentation that we cover in the video. We'll put it under this project game leaderboard, and I'll create all the documentation underneath that. I haven't quite got around to that, unfortunately, because I've been a little bit ill. But hopefully, I'll get a lot of that done in the next couple of days. Right, let's go. So let's go. I do have one I've done earlier, but I will save that for now and just basically do this all from scratch so that we can see what's going on. So if I go to my terminal, I'm just going to create a new project. I'm going to close that down so it doesn't interfere with what I'm doing. Let's create a new terminal. There we go, the projects. Okay, so let's do, and I want to do, oops, there we go. I've got this in my history somewhere. There we go. Nope. Maybe not. Let's type it in. Here we go. So hopefully you can see that's what I'm doing. Let's make that a little bit bigger. Boom. So I'm creating a new Leiningen project using the Compojure API, and it's going to be called Game Scoreboard Demo. We're passing an option to the Compojure API and saying we want to include the Clojure test library. So that will add a little bit extra to the project that we've created. If you've never done this before, it might download a few libraries. I've done this already, so it just uses the libraries I've already got. There's no new versions of those libraries, and they're all saved in the .m2 directory of your home directory. So if you go to .m2, there's a repository. There's a whole bunch of folders in here that represent libraries and dependencies you've already downloaded. So once it's downloaded, you should never need to do that again unless you change versions. So let's open this project. I'm going to create a new layer. I'm going to call it demo. Oops. I am using Spacemacs, but there's no need to kind of use Spacemacs for this. Any kind of Clojure editor will be just fine. So let's open File, Projects, Study Group. There we go. And open that. And I'm going to open the projects CLJ file. And the reason I'm doing that is because the Clojure version is slightly behind. You don't need to change this specifically, but I always like to kind of use the latest version of Clojure where possible. So this is using Clojure 1.8. There's nothing wrong with that, but I'm just going to change that to Clojure 10. And other things in there. So it's got compojure-api as a library. There's a whole bunch of things in there. This is our handler, so we can start when we start our game with using ring. It knows where to go in our code to start which function to call. So it's going to create this handler, and it's going to run this game scoreboard demo.handler app. So when we see that, that's going to load that into Jetty and run our application. And then we've got, when we package it up, we can give it a name. We might give it a better name than that when we get to that. We've got Cheshire, which is a library to help us deal with JSON. So transforming JSON to and from Clojure data structures. So the closest data structure in Clojure to JSON syntax is the Clojure map. So it basically just transforms Clojure maps into JSON and vice versa. And then ringmock is a library for helping us. Is a plugin that'll help us write tests and do some mocking around tests as well. Because it's a server, we can emulate some of the things that the server's doing without having to go through the server itself. And that's it. So these dependencies here are all developer dependencies. They wouldn't be included in the project, but these two libraries would be part of the project if we deployed it. So. Any questions so far? No questions. Nope. Cool. Hopefully, if you've done Clojure projects before, this is all fairly familiar. Hopefully, if you're still new, then it's not too much. I mean, this is just a bit of Clojure itself. We've got a function calling a function, and it's just got a bunch of arguments. A little more arguments than you get normally, but it's still just a bunch of arguments that we're passing to a function, and it just helps us build the application fairly simply. So let's go and look at some of the source files. So we've got a test file. Let's have a quick look at that. It's just got a very basic test in there. So it's using Cheshire to read in some information. So we've got this parse body, which say, I'm assuming that's we're going to read in some JSON code, and it's going to read that and then turn that into Clojure map for us, essentially. And this is just it's using this idea of response. It's going to use the mock library to get to basically call our APIs. And in this case, it's calling a specific plus API. And then it's going to see whether we got a response of 200, which is the HTTP number for an OK response. And it's also going to check if the body is going to read the response, which is a JSON response, and it's going to pass that into a value, and then it's just called body, and then which is a Clojure map, and then from that Clojure map, we're just going to extract the value for key and return 3. So that should all work. Ideally, I should write tests for this, but I've got a feeling I probably will skip tests this time around because I just want to focus on the syntax of creating APIs for now. So let's go and let's open the. So this our source code really is all in this handler.clj file. So let's open that and let's make that bigger. And so this is composed of our schema definitions. We've only got one here. We've got one for a pizza. And then we've got our application. So if you remember back in the project, we defined the entry point to our project, to our application called app. So this is where our project's defined. There's this map here that defines some Swagger information. So this is configuration information. And these are our routes as well. So we'll go through creating some new routes, updating a lot of this stuff from scratch. One thing I'm going to change, because I don't really like single named arguments, I'm going to change this from S to schema, which will break a few things, but I'm going to change a few things anyway. Sitting with each other. Yeah, so I'm going to delete that for now. I'm going to put that at the bottom, just out of the way. I'm going to comment that out. Oops. And then, I don't need those either. Well, I'll keep the plus for now. Really echo, I'm not going to echo a pizza because we kind of removed the pizza definition, so we don't really know what a pizza is now. Out as well. So I'm just using the reader macro comment, which is just a hash underscore. And that basically says tells Clojure to ignore everything in that expression, basically. So, and as it ignores it, it doesn't return any value. It's not trying to call that code. I prefer that doing this to using you can use the comment. You can use the comment block, but if you do evaluate that, then to comment out code, so you can put code in here as well that you don't want to run. But if you evaluate it, you comment, you still get a value of nil, assuming you're running a REPL, which I'm not. There we go. Press run button. There we go. I should run my REPL while I'm sorting this out. Okay, so we've got. So I'm going to put in here some schema. So like. And then this is going to be our application. So this is our application. And then in here, this is our Swagger. So we've got some Swagger configuration in here, and we've got, these are our routes. Oops. Don't type anymore. So this is what we can, so these are the addresses we can go to in our API. And it's got a context of API, which is quite general. We might change that in a moment as well. So let's see, let's save that for now. Any questions? No questions. Okay. And so let me just check what I was going to do. Previous. So this is I guess this is my requirements here. So, and next, there we go. So these are our requirements. Let's paste them in so we don't forget. Just make that into a comment. There we go. We want to define all the scores for our game, show like all the top X number of scores, bottom X number of scores, create a new game board and add a score to a game board. I guess we want to be able to add a player, and show player accounts, So those are our, that's our minimal viable product, I guess. So what do we want to do first? Well, we're going to deal with scores and players. So how do we add a score? Well, we can define a schema for score. So let's use the schema library. And then a desk schema. And this is, so we're basically going to emulate what we did with the pizza here. So this is just creating a map. So in here we want we need to give it a name. So let's give it a score. Oops, I can't type. Score. Then we're going to define the structure of our schema, which is going to be some kind of map like this. This is the pizza map, so we're going to change it. So we want, I guess we want the player. And that's going to be a string. I'm going to get rid of the description for now. And then what else do we need? Feel free to suggest other things you think should be included as we go along. Let's get rid of that. Get rid of that for now. So we actually want the score as well. That would be useful. And that's not right. Let's just evaluate that so it picks it up correctly. Changed it still. There we go. We want the score. So I've got a player, and our player is going to, we're basically saying our player has to be a string to be correct. We're not defining what kind of things go into the string, but it has to be a type of string. So if we have a player, it would be in Fred. Our player, Fred 1, 2, 3. That would be a player, and that would be a valid player because it's in a string. If we had player 1, if we had player 1, 2, 3. Oops, that's not. There we go. If we have player 1, 2, 3, then that's not going to be a valid player because it's an integer. It's not a string. So we can make sure we're getting the right information there. And so for score, that is going to be an integer, so we can use schema. And then there's integer. Oops. Integer. There we go. So that's going to represent, an integral number, an integer, so a whole number essentially. If you use fractions in your game scoring, then obviously you can change that to something else. And there's quite a lot of different built-in types you can use, and you can also define your own types as well. There we go. So there is some types here. So this is an example of some of the types we've got. So any is like obviously flexible, any kind of type. So it's kind of like, it's not specifically typed. There has to be something there, but you don't really care. There must be some kind of value there, but you don't care what the value is. Boolean for true and false. Num for number, keywords, symbol, integer, and string. They're all kind of cross-platform ones, so they'll work with Clojure and ClojureScript. and whatever kind of Clojure host language you're deploying this on. And there's a few others that maybe are relying on the underlying hosts. There's one for UUID, which we'll probably use, that's specific to Java, I think. Any questions? No questions? No. Okay. That's our score player. We might actually want to make the players unique as well. So we could actually include a, so this is going to be a player name. Oops. But then we also want a unique player, so we could have a player ID, and that's going to be a schema. Oops, see if I can spell. And oops, yes, and then there is something called a UUID, which is basically a unique universal identification. So it's a way to generate quite a long number that makes it fairly easy to kind of have a unique representation of a person. So you don't, so people can change their player names, but you still know who they are because you can use their player ID. So we're going to use the schema UUID, which is already built into our schema library. So that's quite nice. And then we could do a scoreboard, because we've got scores, but we need to run a scoreboard as well. And it's kind of, I guess our scoreboard is going to be just a collection of scores. Well, one thing we notice is the convention for schemas is to use capital letters at the start. So let's do scoreboard. And just so it makes it clear that they're type rather than something else, rather than just a value. Okay, so this is going to be pretty much the same, except there's going to be multiple scores in our scoreboard. So the simplest way we could do that is to just put that into a vector. So if we put that around there, and if we bring that in, so I'm just going to slurp that in, so it's all inside there. So basically the map is within inside the vector. And this just means that the scoreboard is going to contain 0 or more scores in there. I'm pretty sure there's a way to define score so you can actually use that as a schema. So I would just put score in here instead of actually putting the specific map in there. And then obviously if you're going to change score, then you don't have to change scoreboard, because that will automatically be updated because it's using the score type. But in this case, I couldn't quite get it working yet, so I think I'm missing something. So I'll look at that. That'll be something to do for next time. We're doing halfway through already. And so let's see, what else did we do? Let's speed this up a little bit. Hopefully this is something you're getting the hang of so far. So this is what I've done earlier. So we did score, and oh yeah, I put in an optional. For the sake of time, I'm just going to copy these, walk through them, because there's quite a few I came up with. No, wrong one. Space. There we go. So these two I've already got in there, so we can cut those. Boom. So I've got score. This one has got an optional key on as well. So I thought it might be quite interesting. So if you list the scoreboard, have like a visual clue about who's who. Then you could use something called like a gravatar, which is basically a way to register like an image for yourself. Go to gravatar. It's like an avatar, but it's basically you can just recognize. You can have like a standard picture for yourself just based on your website, and other websites and services can use gravatar again just as an API, and you can you can basically set just one photo or one image that you want to use for a particular email address across all your different applications and games and things you do. So gravatar is quite a nice little thing to set up, and it's free to use, free to set up, and you can have a bit of control over what gets used and where it gets used as well. So I've made this optional so we don't have to include it if people don't have it, and we could also have optional images that we could upload. Well, especially when somebody's registering themselves for an account, they could register a logo to use, which could be one that our website already has, or one that they upload themselves. And then, so I've got score, and one of the things we want to do is to be able to add a score to the scoreboard. So our scoreboard, we've actually simplified it here a bit and just have the scoreboard as player and score. So this will be the player name and the score that they've got. And if we call, we can also call an API to route to be able to update and add a score or save a score to the scoreboard, which is what this def schema is doing as well. So we've got, and this is just returning the result of whether that score was saved or not. So this is what a score looks like, and when we'll send information to our API to define what that looks like, and then we will use this score saved type to say whether this was successful or not. So if we add a score, then it's always going to be either true or false. We're not going to get back strange numbers or other things like that. So it kind of controls response we get from calling an API. Oh, this is where, yeah, I haven't quite got this. I couldn't quite get this to work for the scoreboard, so I'll have a look at that the next time round. So that's the scoreboard for the types, and we have the player, defining player. So we've got a player account, what that looks like. So we've got player ID, we've got name. Again, we probably should add like an optional gravatar here. In fact, yeah, I think it makes sense to actually put the gravatar in the player when I come to think about it. Rather than the scoreboard. I think it makes more sense to put the gravatar with a particular player. Otherwise, every score has to have a gravatar, which I don't think makes as much sense. So I'm going to cut that out there. This is a nice thing about software. You can come in and change it. That's what it's designed to be able to do. So let's create. Let's put that in there. Let's paste that in there. There we go. I just put space. I mean, I just put space in here. There's no reason to put space in there in terms of syntax, but I put space in there just to kind of separate the values that are required and then the optional values as well. So you can see very quickly at a glance which ones are required and then which ones are optional. I haven't seen a particular syntax that kind of shows that, apart from just seeing this as well here. Obviously, you've got the optional key. It's quite visible, but I think it just helps. It also helps line up the code and makes it a bit more readable in my eyes. But so we've got player account, and then we got all player accounts. So this is what we'll do to just list all the player accounts. So we got an API route which will just list them. Then we can just get the player ID and then the name. And again, we could probably put in here the optional gravatar if you wanted to as well. Let's do that. Yes, is that still be in the my buffer? And the gravatar is just using a string. I'll need to check if there's this is like a URL type instead, but for now I'm just using a simple string, and we can put in either a URL or an email address. I'll need to work out which one is best for that particular thing. And then if we want to create a new player, then we just want to make sure that somebody's passing the new player in as a string rather than any other type. So when you're registering, then the name of the new player is going to be string. It's not going to be a number. It's going to be a string, so it's of the right format. Again, that just helps it make our code simpler if we're checking and putting a type contract on our API as well. Ooh, no questions still. Everybody's still there. Excellent. And let's see. So those are all our types, and I didn't create them all at once. I didn't create them all up front. I kind of evolved them. Usually I was creating a type and then creating a route for it as well. Ideally, I should have created a test and then a type, and then a route that would satisfy the test, and also make sure it was valid by the type as well. That would be the way I'd normally do this kind of thing. Any questions on type? No, it doesn't seem to be. Let's dive into the Swagger configuration. So this is hopefully fairly straightforward. This is just showing you where to access things. So the user interface for Swagger is at the root of the website, and if you go to this JSON, this swagger.json route, then that's the specification for all our APIs and our types and so on. And this is just this is just metadata information that helps you just use the Swagger interface a little bit easier. And I'm going to call that game, and I'm going to call that just to make it more specific to what we're doing. I could also change this API to a game or a name of a game. We might have several games that we have scoreboards for. That's probably a very good idea. If we've got multiple games, we just have a different context here. So instead of we could just have a game, or we could have the name of a game, like Waffles is one game. We might have another context, which is let's see, where would that go? That will go there. We could have a second game, and that would be and so you could go to different scoreboards based on the name of the game, and underneath that you get specific scores and scoreboards and players for those games as well. And you could just keep adding more and more contexts for particular games that you were managing a scoreboard for. So let's kill that for now. Let's just simplify that back to game. Oops. And we've got this route, but we don't really want this route either. So we want to create a new route. Oops. rid of that root in a moment. Let's do, so we want to get, so this get is the type of HTTP request. So when you click on a link in your browser, then that translates to a GET request in terms of HTTP. Thanks to Tim Berners-Lee for inventing it 30 years ago. And this will go off and get a particular resource. It'll get back a web page. It'll get back some piece of information that you want. In our case, it's going to be either a piece of JSON, or we can also get back Eden, which is the file for the data format that Clojure uses. And so we need to tell it what address to get. So we can get score and board, and then we can do some destructuring if we want to basically pull out information from the request. So there is still a request object coming in. So that request object might be a JSON file. It might not be. If we're doing a post, then there might be like a JSON file there. If we're uploading a file, then obviously that's going to be part of the request. But there's just general request information as well about what browser you came from and other such information as well. But we're not really going to use that at the moment. And then we specify what kind of data it's going to return. It's using the return keyword. And this, in the plus case, this is just going to return like a long integer. So basically a potentially big integer whole number is going to return. So as long as you're returning like 1, 2, 3 or 1,000,000 or 6,000,000, then that's fine. If you're returning a string, then that's going to cause this would pick up that as an error. So in our scoreboard, we want to return a scoreboard. We want to return something that looks like a scoreboard, and we can then also, what else do we want to do? So if we look at the pizza one again, oh yeah, we can define a body. So like if we need to pass information into our API, we can define what that looks like. We don't need that for now. We're only just getting the scoreboard. There we go. And what else? There's something I'm missing. Let me just check. Oh yes, there we go. No, there we go. Oh yeah, and then we obviously need to return. We only need to define what the value is. So let's grab these. Oh. Oh, oh. So with the magic of technology, there's a whole bunch of routes I've done earlier. Let's get rid of those. Just make sure I'm not, yeah, I'm deleting the right ones. There we go. Questions? No questions yet. So what have we got? Ooh, it goes by fast. So we've got a scoreboard. So we can go to scoreboard and get the results. We can, and it's going to return scoreboard, which we haven't actually defined. So I want it to return a scoreboard, but we'll need to define some data for that. We need to define what that scoreboard looks like. And so before our application, we can define some data. And so we can just do a normal def, to give, what was it, score? We're going to define scoreboard, and that's going to look like a well, the schema. So our schema was a vector of one or more maps. So we can have a map. Oops. And that would need to have where we go. There we go. So we got player ID. Oops, that's players. Let's scoreboard. There we go. So it'd be like this, and instead of the types, we're now kind of adding in some example data. So we wanted to precede a few scores in there. We can do that. So instead of schema, we can put in a player's name. So that needs to be a string. Peter is the player's name, and we can give them a default score, and that's going to be an integer. So we can give it like 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Nice big healthy score there. And we can create several of these players. Obviously, in this case, we're not checking whether there's like unique names, so people can have unique names in the scoreboard. So have names that are the same. Underneath, we're going to know because we're going to use a player ID, but Peaches. Having a thing for peaches and waffles at the moment. I'm not sure why. There we go. But there we go. And then you can have a different score. Boom, boom. So Peaches is obviously just starting out playing the game. And so that's our structure, but ideally we'd push this into a database, as I mentioned before. So we'd have persisting of all our scores. But we're going to cheat a little bit, and we're just going to use something called an atom, which is a way to be able to manage changing the state of things. So we're going to change the state of the scoreboard, and we can swap in and swap out new versions of the scoreboard using an atom, and we can do that in a safe way so that if several things are wanting to update the scoreboard at the same time, then only one is allowed to do that at once, and it's the atom that is actually managing that. So an atom is like a box that can contain pretty much anything, and what it contains is still going to be an immutable piece of data like a map or a vector, but we can change the contents of that box as often as we want to, and it just gives us a simple way to kind of manage that state without having to write any code ourselves to control when people are allowed to update the contents of the box. Let me slurp that in. So Control K. Slurp. Now the atom, it contains the vector, which contains the two maps that define our scores. Ooh, we're getting close to time, and then let's have a look. Oops. Oops. And we have got a bunch of yeah, so we've got scoreboard here. Actually, I might as well just keep on using this one for now. It probably makes more sense. Let's make that a bit bigger. There we go. And I started doing the same thing. So I've got an atom for a scoreboard. I'm doing the same thing for player accounts as well. Haven't quite finished that off yet, but again, you would just do, well, I think, yeah, player accounts, you would just put in the kind of maps that represent each player in there as well. So you could just have a player account that's an atom that is just empty for now, and then you just go and add things to that. So how do we actually add things to that? So that is a good question. Let me just go back to the previous one. I'm just going to close that REPL for now. Yes, I do. Why is it not killing? Okay. Yeah, it's gone a bit weird. Sure what was going on there, but anyway, let's hope we've got enough to run another REPL. There we go. There we go. So I'm just starting a REPL up in here. If we go down to the bottom, I've been doing some REPL experiments. So let's do, there we go. So because we're using an atom, then if we wanted to get the value of the scoreboard, we have to use this @ sign in front of the name. So we just do a normal def fish, and then so if we just do a normal fish, we're basically just defining a name called fish, and we're associating it with the value haddock. That could be anything. And then if we evaluated fish, then that would return haddock. But because we put our scoreboard into an atom, we can't just do scoreboard and get the results. It would actually just give us the address, the reference to that atom. So we actually just want the value from that. Then we can put this ampersand, this @ sign in there, which is the same as doing a function called deref. Oops. So those two are the same, essentially, and it just allows us to go off and get the information just as the raw information, so a vector of maps in there. And this does the same thing here as well. So we get those values in there, but that's how we read them. If we want to write to them, we can't just use a normal function. We have to use it inside something called swap or reset. So swap basically swaps the value of from the cardboard box that is our atom. It swaps the value out of there and puts a new value based in there. And so swap is a function, well, actually it's probably a macro that actually takes arguments that is the atom name itself, and then the function we want to use to be able to update the value in the atom, and then any kind of value that goes with the function. So in this case, if we look at scoreboard, what that is now, there we go. So scoreboard has got several players in there. So it's got Waffles with Peaches, player 21 in there as well. If we go in and go in and actually evaluate this function, then this is going to conjoin player REPL. Oops. Why is it doing that? There we go. Yeah. This is joining player REPL onto the game board, the scoreboard, And so each time we can use the atom to kind of keep track of the players that we're adding. Because we're using an atom and not using a database, then if we stop our application and stop the REPL and then restart it, then everything goes back to the default. But it's a nice way to kind of shortcut the things we want to do for the moment. And you can also use something called reset as well, which will set it back to a specific, set the atom back to a specific value. So I'll include an example of that later as well. And then we can also do the same thing for player accounts. So we've got all our schemas. Let's recap what we've got so far. So we've got our schemas, and then we've got our scoreboard, our game data that we're including. I've created some helper functions, which we'll come back to in a minute. And let's look at the routes that we've created. So we've got get scoreboard, which will just get us the current value of the scoreboard. And this is just returning basically the dereferenced scoreboard. So that will just return a vector of maps, but it will return that in JSON if that's what we ask for, or Eden if that's what we ask for. In the actual thing. So if we go into scoreboard. So to start this application, to start our thing, we can do line ring server. And because we're using the ring plugin, this will take care of all the reloading things for us as well. So it's not the same as just doing line REPL. Line ring does several extra things for us. So it starts up Tomcat and injects our application into the application, and it also opens up the browser for us as well into the right location. And so this is our Swagger interface. This is the data it's using. And it doesn't look like it's done much, but if we click on this show hide thing, then it shows us all the APIs that we've created. These are all the descriptions I've added to the scoreboards as well, and to the API scoreboards. And it's going to showing them in the order that we've got them into, that we wrote them in the code as well. So if you wanted to change that, you just reorder them in the code. And so the simple ones, so if it's a simple get, then it's just showing you the results of, the response, what that's going to look like. So you know the types. So if you're going to consume that, so if you want to do something with the response, you know what the shape of it is. And this is, if you haven't seen this before, this is a vector of maps, but in the JSON format, because that's the response type we've got selected here. Let me just, yeah, there we go. That's not too bad. And then if I change this to say Eden, then you would get slightly different kind of response. You would get the Clojure response rather than the JSON response. There's also Transit, which is another library for helping you deal with data structures across lots of different types of applications. But we'll come to that in a different lesson, I think. So if we try it out, then it's just going to basically call this game scoreboard address. And it's showing you alternative ways of doing that. So we can actually do that from like the command line, and we can do this from just going to a web address. So that's what we get if we just go to the web address. We're actually just getting the data just pulled back. And if we look at the page source, it is just the page. It is just basically exactly what it looks like. We're just basically showing the JSON file, the JSON data, raw, as it were. So that's not not useful in itself. It doesn't make a pretty website, but we can make make our website look. I could consume this information and represent that in a nice way at some point. So this is showing the body that we've got back. It's been successful. It's got a response code of 2. And so that gets pretty straightforward. A post, we have to actually supply some information. So the response class, we still get the same. It shows us what we're going to get. So if we have a new score, we want to register a new score, it's going to tell us whether the status is true or false. So if we don't send the right information, it'll tell us false because the score wasn't added. And yeah, and then we have to obviously try again with the correct information. And the second part of this is showing you the parameters and the kind of the data type that you can use. So here, this would be the JSON that we would actually send. Or if we selected this, we could send different information if we wanted to. We can send YAML and other formats as well, but we'll stick with JSON because it's more common. And yeah, if we actually click on this little example value, it'll actually copy it into the actual value here, and we can go in and edit it and do I'm not being particularly imaginative with names, unfortunately. I guess that wants to be, that should really be, we've only got it set to a string at the moment. We haven't got this set to a UUID. But if that was a if we did change this to UUID, then we'd obviously have to supply something in that format. Just to keep it easier, we've got, there we go. And the score of 42. And we're going to, we're not going to, yeah, we'll leave the gravitar as it is. So this is the data that this, that calling this particular route is going to pass along with it. So again, we can also try this out, and it shows us whether it's going to be successful or not. Oh, we got an error. Oh, okay, yes. So this is picking up the fact that we're not using waffle. So I've actually got a bug in here that I would need to go and fix, because my schema is saying that we need to use a UUID, and we're actually just using a string which is not of the same type. So we get a different response code, and at least we know very quickly whether we've got something that works or not. So we need to go back to the code and see what was occurring there. So look. Score, yeah, so that needs to be a UUID. I'm not quite sure why that's not picking up there on the so this body should be, oh, that's interesting. Yeah, so this body should be showing as a score, and it should tell us in the, should be telling us here actually that the player ID is a UUID. I'm not quite sure why it's not doing that, but we'll oh, unless maybe JSON doesn't support that. I don't know. Interesting. Anyway, something else to have a look at, and I'll get back to you about why that's doing it. But you can see very easily that the error messages are fairly straightforward in this. So it's showing on the response body. So this is what you would actually get from the API. So you still get it wouldn't fail. It would actually give you a value, except the value this time is showing you that there's an error in your request. And it's giving you a pretty good indication of how to go and fix it. So it's saying that when you sent that player ID in the JSON thing, it didn't look like a UUID because waffles2 as a string is not the same type as a UUID. So it gives you plenty of chance to go and fix it in that respect. Hello, kitty. I think my cat's trying to tell me how to fix it, but I don't understand what he's saying, unfortunately. We'll debug later on. Is that right? Yes, we'll debug later on, yes. And then for new player, what do we got? Oh yes. So new player, I'm just passing in a string. So we want to register a new player account. So we just come up with the name I want. So we would have some kind of form, like a registration form, and one of the fields would be kind of your player name. And then when you submit the form, it goes off and updates. It calls the API and then uses this name to update the list of players. And then we can go and try it out, and we should get back a confirmation of the name and the player ID. So the person gets their kind of player ID. So that's what a UUID looks like. I could actually use this. Oh, yeah, I wonder if I could just use that and go back to other example. There we go. Yeah, let's change that. See if that works. It's always good to experiment. That's the nice thing about software is you can just keep on experimenting and seeing if things work. Try it out. There's still some buggy stuff to do there. Okay. Some more experimenting to do this afternoon. Okay. And what else did we do? And then we did similar things for player accounts. And I also did like a random score, just as a simple way to test things out. So we get, we just get a random score each time. So we got here, writing a player with a random score, and then it's just returning back the scoreboard for us. So it's just a way to test out whether the scoreboard is being updated. So let's have a quick look at that, and I think that will wrap us up for today. Let's see. Yeah, so random score, it's going to return a scoreboard. So that's the type that we've defined. So that's going to be a vector of maps, and each map is going to be a player and their score. And summary is just telling us what they is. So this summary is going directly into the Swagger documentation we saw before. So we saw here that it's the documentation for this API, so it's a lot easier to get some context about what it's doing. And then we're actually just, so the actual logic of this, calling this API, it's going to return a value by evaluating this expression. There we go. There we go. And so, as we saw earlier, we're going to update by swapping a new value into the atom that's called Scoreboard, and we're going to use conj, and then the value we're going to use is just by generating this random score, which is a custom function I've written myself. So at the top we've got here we go, random score function, which doesn't take any arguments. It's just going to generate a random player name and the random score. So we're just using rand int up to a maximum of I don't know, 1 billion, 1 trillion, and the random player ID is just basically doing player and then a random number. So player 1, player 1000, player 357. So it's just a simple way for me to do some testing. Ideally, I could probably just fit those into some interesting unit tests as well. And that would be give me a bit more robustness in my application. And we've got things like random UUID, which will just generate it. So this is using Java. So again, this bit wouldn't be portable to other platforms that Clojure runs on, but it will run on the JVM. And so we're just using a JVM function to call random UUID, which will just generate as that number. And we've also got this for player account as well, which will generate a new random UUID for a player. So when you go to new player, it calls this account, new player account, and generates, it takes the name. This one does take an argument of name, but then generates a random ID for it as well. So if you look at player accounts, oops, there we go. So this returns a player account. So we get a new player account, and that's the specification it's going to return on. And this is the body of that new player. So we're going to return exactly what a new player is, and this is used to the documentation to the Swagger interface. Summary there, so we know what we're doing, and then we're just calling a function. Work is just calling a function new player account, and then we're just getting from new player. We're just getting the name, the value that the keyword name points to. So when we call the API, we're passing a name in. Let me show you that again. Yeah, so we're passing a name in here. Where did the new player go? Yeah. So we're passing a new name in here as part of the JSON file. So this is being pulled out because this is converted into a normal Clojure map once it gets into the Clojure world by Compojure API. The Compojure API turns that into a new map. So this new player is essentially just a map from the response. A map from the request that we received. So the JSON request is turned into a map, and we can access that through new player because we're just doing a local binding here. So this is a bit like a let binding. And then from that new player, we can say from that map, we just want the name of the value that the name points to. So this would be Fred Jones from our previous example. And then it's going to call new player account with that. And it would then, is that going to work? So that's going to, oops, no, I missed. So then we go in here. So the name is pulled out. So we don't need to do any extra work here. We've already got the name Fred Jones in here, and then it's just going to create a new player, and off we go. And so we would need to add that to the. So we'd also need to put this into a swap thing if we wanted to add that to the actual player account list that we're managing. So we would do swap just like we did with the random score. We would just put swap around that. So we guess it would be like swap scoreboard. Oops. And then we're going to swap a new value into no, it's not going to be scoreboard, is it? It's going to be player accounts, which is the atom, and then we're going to just conjoin that with a value that we're going to get from putting that in from the new player account. And there we go. And then that will just allow us to update a new player account and keep a list of those as well in our atom. Okie dokie. Well, that's we're about 14 minutes over. Hopefully that has been very useful. I'm going to finish this off and tidy it all up and add some more documentation to this too. So it's if there's anything you didn't quite follow, you can have a look at that information as well. And I'll put that up on the website, the Practicalli website. Oops, wiki. Under the Serverside API projects game leaderboard. I'll push all the details of how I got there and all the design we've worked through. So because just as a recap, we've done quite a lot. We've designed a whole bunch of values, a whole bunch of types we want to use for our data. So the data that we're getting in, like score, and the results of processing some of the data, like score saved, and the data that we're tracking, scoreboard. All the data that we're working with is pretty well defined. So we know if we get some bad data, and this is usually where most of the problems are with software, is you get bad data in or send bad data out. if we're putting these schemas, these type definitions around that data, then with a lot more security in what's actually going on, and at the very least we can trace what the issues were. Yeah, so it makes a nice safe thing there as well. So we've used, in this one, we've used climatic schema, but we could also use, people are also starting to use clojure.spec as well, which is a really nice way to define everything as a contract, both your documentation, both your data structures and your functions as well. Okay, thank you very much for listening, and feel free to give me any comments and feedback about what you'd like to see. And in future episodes, we'll actually take this and actually consume the data and display it into a website. And one of the things we want to also do in the very near future is also rebuild the Clojure Bridge website, which is nice, but I think we can make it a lot more interactive. So it'd be nice to have this Clojure programming workshop as a ClojureScript website. So if anybody's interested in working on that, let me know. There's some images there, and this is just deployed on GitHub pages, so there's no big kind of deployment to do. It's just basically if you can write it in ClojureScript, and then we can just generate the index page and JavaScript page, and we can just deploy that straight onto GitHub pages, and make this a bit more of an interactive experience for people who are interested in learning Clojure as well. Okay, I'll leave it there. Thank you very much for listening, and I'll see you next time. Thanks very much. Goodbye. Bye.